Alright, hey, we're going to do section 8.1 today. And I want to start with just comparing an idea, looking at two different styles of solving. So, first off, we know how to solve this. I just want to compare it to another way of solving that we'll talk about in today's lesson. Usually we see the x squared, and so far in the lesson, or in this course, the only way we've known to solve it is to move everything over so that it's equal to 0, and then factor. If it factors, thankfully this one does, and then set each factor equal to 0 and solve each one. So we see here that we get two solutions. X equals positive 3 and negative 3. But I want to talk about another way to do this. So looking over here, just the last few sections we worked on solving radical equations, and we learned that the opposite of a square root was a square. Well, if the opposite of a square root is a square, surely the opposite of a square is a square root. So I'm allowed to square root both sides, and that will leave me with nothing but the x on this side. But then we have to be careful. All last chapter we just said the square root of 9 was 3, taking only the positive or the principal square root. But remember, we discussed that this thing has two roots, because positive 3 times positive 3 does equal positive 9, but so does negative 3 times negative 3. That also equals positive 9. So this has two answers, positive and negative 3. We have some lazy notation, lazy way of writing this, using this plus minus sign. It means both answers at the same time. So now look, this is pretty awesome. We have another way of solving the same problem that takes less steps, and it's not relying on the fact that we can factor it, because a lot of things don't actually factor. So let's try another example. Let's try a pretty simple one, like x squared equals 16. I can solve this so that this thing that we're doing is called the square root property. So we could solve by trying to factor, or we could solve by using the square root property. And this works when I have something squared all on this one side. So then I'm allowed to square root it, and that'll be positive or negative 4. We can do more examples like this. We can go with something that's not a perfect square root. Now you would not have been able to factor this one if you subtracted over, so this is awesome that we can gain this. So x equals positive or negative square root of 50. Now we do have to ask ourselves, 50 is not a perfect square, but can we simplify 50? The answer is yeah, we can, because there is a perfect square that divides evenly into 50. That'd be 25. So I could rewrite these two things as 50 as 25 times 2, and then break them into their own radicals. This is all from last chapter. And the square root of 25, we know that that's going to give us 5, square root of 2. So this is pretty awesome, because we wouldn't have been able to solve this one. Now I do want to discuss a little something extra. So everything has just been x squared on the left side of the equation so far. What if I throw more stuff around it? Like this. And so we'll look and we'll say, hey, if I square root this guy's going to get caught up in that square rooting action. So I'm going to want to get rid of it so that I only have my x squared here. Well, we know how to do this. The operation between these is multiplication. So the inverse operation, I can just divide both sides. Those things are gone. And so here's where I'm sitting in the same type of problems we've been doing. I can square root both sides, and x equals the positive or negative square root of 7. Now the square root of 7 doesn't simplify, so that's actually pretty easy, and we're done right there. Now I want to kind of expand this idea. What if I had something else squared? Not just an x, but an entire, let's say, polynomial squared. can I use the square root property to get rid of that? And the answer is yeah. As long as I have something squared with nothing outside of that, I'm allowed to square root both sides. And so this will give me positive or negative square root of 12. And then, of course, we need to simplify this 12 square root of 12. It does simplify. I'll jump right to the simplification, but if you don't understand that square root of 12 is 2 square root of 3, you can just easily break 12 into 4 times 3. Give them each their own radical, and the square root of 4 is just 2. Okay, awesome. So now, have I finished solving for x? No, it's not all by itself, but it's pretty easy to solve from here. We just have to subtract 1 from each side. And then x equals positive or negative 2 times the square root of 3 minus 1. Now, this cannot be simplified anymore because those two terms can't be combined since they are not both like. They both don't have this square root of 3. That's from the last test. We studied things that make things like. So that's pretty awesome, right? So we can do more just like this as well. X plus 3 squared equals 16. So all of this works because I have something squared over here. So I can go about my business solving it. Square root both sides. X plus 3 equals positive or negative 4. Then I can subtract 3 over. Now, since this is going to simplify, these can combine, I need to carefully think about this as the two separate, two different answers that we have. Two different. So that's positive 4 minus 3. And then we're looking at negative 4 minus 3. Be very careful because people are tempted to say that's, hey, that's positive or negative 1, but it's not. They're actually two separate answers. 4 minus 3 is 1. Negative 4 minus 3 is negative 7. So we get two very different answers for that one. Okay, so we can expand this to even nastier, bigger problems without too much stress, though. Put more in the term that's being squared, and I'll make it easy. Give us something that's not a perfect square. So when I use my square root property here, I'm left with 2x plus 5 on this side, and plus or minus the square root of 19. Now, square root of 19 doesn't simplify any. 19's prime, nothing divides into it. That's a perfect square. So that's as far as I can simplify this guy. So I just need to go about my business solving for x. I can subtract 5 from both sides. So 2x equals positive or negative square root of 19 minus 5. And then divide both sides by 2. Now I have to divide the entire side by 2. So be very careful of that. Now nothing simplifies here, reduces or combines. So these are this represents our two answers. Okay? So awesome. I'll do one more like this before I go on to kind of the last idea of this lesson. So another one very similar, but I'm going to give it a negative number on this side. So this was the very last lesson we worked on in the last section, was how to deal with square rooting a negative number. So we know we have 3x plus 7 equals something. We need to talk about this. Remember the idea that I can simplify this by rewriting it as a multiplication. Well, 16 times negative 1 is negative 16. You would agree, right? Well, then I can break them up into their own radicals. And when I square root 16, that's going to give me 4. And remember, square root of negative 1, we called that something. We called that I. It's a complex number. So the square root of negative 16 over here, of course, I have to still think plus or minus. I can simplify that down as 4i. Okay. Now I can go about my business solving. Subtracting the 7 from both sides. So 3x equals plus or minus 4i minus 7. Then dividing both sides by 3. So x equals positive or negative 4i minus 7 divided by 3. And I can't do anything to combine terms or anything because this term has an I and this one doesn't. So there we go. Alright, so one last idea here before we're done with our lesson is the idea of if I don't have just a perfect square over here, something squared, could I make something squared? I'm going to leave a little bit of space right here. So here's the idea. When we did one like the first one we did was x plus 1 squared, if you were to FOIL that out, that's a trinomial, right? X squared plus 2x plus 1. So the idea is, can I make this a perfect square trinomial? What am I missing? I'm missing something right there to make it a perfect square trinomial. Now we have a basic rule in algebra. I can add anything to the left as long as I add it to the right. So I'm allowed to add anything I want here. So when we're looking at these, there's a very, very simple way to do this. The pattern for these perfect squared trinomials tells us that if there's no number out front, which is that's all we're going to do right now is no number in the A spot, no number out front, we take the second spot and we just want to half it, then square it. Because of the pattern of perfect square trinomials, that'll tell us what number to add right here to create a perfect square trinomial. So take 6, half it would give us 3, square 3 would give us 9. Now if I'm going to add 9 to one side, I have to add 9 to the other side. Now look at what we have here. This factors into x plus 3 times x plus 3. It's a perfect squared polynomial. I guess I could go ahead and add those. But I can write this as x plus 3 squared. And 4 plus 9 is what? 13. Then I could square root both sides. And so, oh, that's an ugly x. X plus 3 is equal to plus or minus the square root of 13. Subtract 3 over, and that's all we're going to do. X equals positive or negative 13 minus 3. We've solved for x. So that originally is a problem that would not have factored, but we created a perfect square by doing this halving it and squaring it. So let's try one more of those before we call it a day. Let's see, it doesn't matter what number I use. I could do one like this. Notice this time the only difference is this number is in the way. So we know how to move it out of the way though. We'll add 3 to both sides. So x squared plus 8x plus blank equals 3 plus blank. Whatever I add to one side, I have to add the other. So let's see. Half of 8 is 4. 4 squared is 16. So if I add 16 to each side, this will factor into x plus 4 times x plus 4, x plus 4 squared. And this is just 19. So now I can solve it in a simple 2 steps. Square root both sides. X plus 4 equals the positive or negative square root of 19. And then subtract the 4 over. And of course, nothing simplifies here. Awesome. Alright, well that's all we got for you today.